Here we go, guys and girls. We got a hot plate set to 230 degrees centigrade. That's the set point. The actual temperature is reading 230. That's the temperature of the metal block or the metal surface. And I got some mildly boiling water there with a separate sensor. That's a PT100 sensor. And 100.3 is pretty close to 100. This inside here has a type J thermocouple. And let's see how the surface of that matches with this sensor. I would give some credit to this sensor, at least around the temperature of 100, because it's reading what we think the temperature of boiling water should be. There. I'm laying that on the surface of the metal hot plate. Over to the side. Over to the side. Let me kind of pinch it down to the surface there. It's going to start to rapidly rise there. This is holding steady at 230. You see on the left the pulsing green light. That pulsing is maintaining the temperature. 212, let's see how that rises. 220. Up, shooting up above. So we do have some discrepancy in. Quite a bit of a discrepancy. In that reading and that reading. So yeah, this one's about 30 degrees off, if that's already climbing towards 260. Let's see if that's my hand's getting a little warm there. I'm going to just kind of release that. 257. 260, and that's definitely about 30 degrees off. So the sensor in here, the type J thermocouple, at least where it's at and where that's at, has a temperature difference. So one of them's not right. But if you're going to do a reaction in that test tube, obviously 200 degrees is not even close to 100 degrees. Because we've got the heat has to pass through the glass, and it loses the heat to the air. So a lot of losses there. That's why the surface has to be fairly much hotter. So what we need in the end is to take a sensor that drives the heating, but the sensor's in the final beaker for our ultimate goal. All right, thanks for watching. Yeah, we definitely have like 35 degrees. Well, it's holding steady at 263 instead of 230.